Hello everyone. I want to look in this example at the idea of so-called coupled reactions and linking that to limiting reagents. So what coupled reactions are is that one reaction happens and that forms something, some product. And then that product is then used in a subsequent reaction that then forms. So hence the second reaction can only occur and its masses and yields and whatever is dictated by what happens in the first reaction. So an example of this is when palladium metal is deposited on a dosimeter and we say, let's say take 10 gram of propane that reacts with oxygen gas according to the incomplete combustion reaction given below. So this is our first example of incomplete combustion. It says here we can assume 100% yield, so meaning we can assume that there's enough oxygen to react with the propane. So hence the propane is going to tell us something about the products that form here. And we need to identify that, well, there's a carbon monoxide and there's carbon monoxide. So hence, carbon monoxide is formed by the combustion of propane, and that is then caught by the palladium catalyst here. And the only place that carbon monoxide can come from is the palladium here. And the question is, how much palladium then is formed here? So hence, the linkage is the propane to how many moles is there. This then tells us how many moles we have there, which will then tell us how many moles can be formed there. And that's how these reactions are coupled, as well as how they are limited, or the limiting reagent plays a role. So we're told initially the mass of the propane. So C3H10's mass is, we're told it's 10 grams, 10 gram. And of course that means the number of mole of propane with its molar mass being 44.094 equals to 0.2267 mole propane. Right. So that's how much propane we have. The question is, how much CO can we get from that? So the number of moles of CO that can come from that much propane is that 2 mole of CO is formed for every 2 mole of propane that reacts. We have 0.2267 mole propane reacting. And that then gives us the exact same number, 2267 mole CO that is formed. Okay, so then in the second reaction, the number of moles of CO can be linked to the number of mole of palladium. So the number of mole of palladium is going to be equal to, it's a 1-to-1, so you can immediately write it, but I mean, let's be frivolous, and we can write there's 1 mole palladium that forms for every 1 mole of CO that reacts. How much do we have? We have 0.2267 mole CO that reacts. It's going to give us 0.2267 mole palladium. Then finally, the mass of the palladium is going to be equal to the number of moles times the molar mass. So This is 2.2267 mole multiplied by 106.42 gram per mole. Remember, palladium is an element on the periodic table, so you just look it up. It's going to give you 24.1 gram palladium deposited. That's the question. How much metal is theoretically deposited? So 100% yield theoretical. And three significant figures, yes, 10.0 gram deposited. Okay, so that's how a coupled reaction works. It's one reagent gives a product, that product is then used again as a reagent in a subsequent reaction, and that dictates something about a final product in the second reaction. All right, and you use your mole ratios and use a reaction stoichiometry to relate everything. All right, thank you for watching, and I'll see you again in another video.